Bro, you are not even allowed to ask such questions in cosmology.
Hey, welcome back to my channel Aesthetics of Cosmos. I am Raghu Kumath, an integrated PhD research fellow at ISO. Continuing my series on cosmology. So in the previous video, we talked about what actually is the Big Bang model of cosmology, also known as the standard model of cosmology. It's not actually about any explosion happened in the pre-existing space at any point in this universe. It is actually about expansion of space itself, or you can say explosion of space itself. But what actually proves this expansion? It is cosmological redshift, which I talked in or explained in my previous video. Please check it out. Now here is a more interesting point to tell you that the expansion is not constant, it is accelerative. Means the farther is the galaxy, the faster it is moving away from us. The farther and farther it is going, the faster and faster it is going away from every other galaxies. So, and here is the acceleration formula for from this theory. The h is the Hubble parameter, which is considered to be as constant today, and r is the distance from the origin. So the more is the r, the more is the a, that is acceleration. And now coming to the interesting questions some of you asked in my comment section in my previous video on YouTube, like if everything in the universe is expanding, why are not we expanding? Why are not the things around me expanding? Like why is the sun, why is the earth, why are the planets not expanding? And what happens like the places, is the space near the black holes? So generalizing these kind of questions into one question is that why is the cosmic expansion not applicable at smaller scales? So I have two answers for this. The first one is like compare the forces with the cosmic force of expansion. Now take the acceleration formula and multiply it with the mass of the object. You will find the force due to the expansion on acting on that body. Take suppose the example of Earth and Sun. Compare the weakest force, that is gravitational force, with the cosmic force of expansion. You will find that the even the weakest force, that is gravitational force, is about 10 to the power 21 times stronger than the cosmic force of expansion. That tells you that how weak is the expansion for these local planets are. Even the planets, even on the planets, it is weak, very weak. So we are, for us it is very very much weak. Secondly, take an analogy of expanding balloon. On its expanding surface, take a point and take the neighborhood of that point. Look at the neighborhood of that point. What you will observe that the expansion is negligible locally. So in mathematical sense, or in mathematical words, I will say that the general metric should turn into a flat Minkowskian metric where the expansion is not allowed. But my personal question is that can I even ask this question of whether I will feel the expansion at local scales, because the theory is originally defined at large scales based on the cosmological principle, which I will tell you about in the next video. But what do you think about it? Let me know in the comments.